Hey everyone, today we'll be talking about our telemetry project with a specific focus on the crash telemetry. We'll have a telemetry overview. We'll talk about the motivation for this project. We'll touch on architecture. We'll have a dashboard demo and some success stories. So Ceph Telemetry is the service that lets clusters phone home to report anonymized and non-identifying data about their installation and configuration. The data is aggregated and presented in public dashboards. It's telemetry-public.ceph.com. And the telemetry report is compiled from several channels, each with a different type of information. And once the user is opted in, the telemetry channels can be turned on and off. So currently we have 5 channels. We have the basic channel that has some general information about the cluster, like the Ceph and kernel versions, the cluster size, number of daemons, and so on. This channel is on by default. We also have the crash channel, which has information about all the crashes that happened in that cluster, and the information is like the backtrace of the crashes and exactly where in the Ceph code the crash occurred. This one is also on by default. And then we have the device channel that has information about the health metrics of all the drives in that cluster. It's mostly smart data. We collect NVMe metrics where applicable, and we're working on adding some vendor-specific metrics as well. And this one is also on by default. And then we have the ident channel. We let users have the option to identify themselves if they want. This one is, of course, off by default. This channel has the contact name, email, or organization, and so on. And in Quincy, we added the cluster, the perf channel, which has information about the cluster's performance counters. And this one is also off by default. It's really important to emphasize here that by default, telemetry reporting is off. Users need to explicitly opt in by agreeing to a CDLA sharing license. And they can do that either by a CLI command, Ceph telemetry on, or with the Ceph telemetry, with the Ceph dashboard wizard. And reports can be previewed with Ceph telemetry show-all, and in Quincy, the command would be Ceph telemetry preview-all. I want to talk about privacy before we continue. We require to re-opt in on Ceph upgrades. So in case we changed the data model version, users will be required to re-opt in. And in Quincy, we added the option to keep sending the version that is already opted into in case the user is not opted into the new data model. The reports don't contain any sensitive or identifying data like pool or host names and object names or contents. We anonymize the reports. So the cluster is assigned a random UID, which is there for telemetry. This is not the FSAD. The FSAD is not reported. We also remove the disk serial ID in the device channel, and we never store IPs on our backend. We also have separate telemetry reports, one for the anonymized cluster data and one for the anonymized device health metrics, and they are sent to different endpoints. So why do we need all that? So the motivation to have telemetry for developers is to get feedback on what features are in use in the wild. We can learn about the upgrade cadence and version adoption rate from the basic channel. From the device channel, we can see what hard disks and SSD models users are deploying in the wild. And in the long run, it helps us to create an open data set of device health metrics, which helps research to come up with more accurate device failure prediction models. And with the crash data that we have from the crash channel, we learn about new bugs and issues in the wild as soon as possible. It helps us to prioritize issues and focus on the most common bugs. And we can also learn about crash trends throughout different versions. And once we provided a solution, we can verify that it actually works. So we can identify regressions, or if we thought that the solution actually, we thought the solution works, and we discover that the same issue repeats in newer versions that has the fix. For users, the motivation is to validate their installations by looking at what is common, what do other Ceph users are doing. In the long run, it helps to preemptively mitigate failing devices. Once we have more accurate failing prediction models, users can preemptively mitigate these devices, which reduces downtime and shifts downtime to maintenance window other than peak hours. With the crash information, users do not need to actively report issues or open tickets for each crash. So all the automation around it saves a great deal of time. And users can also use the open dataset of crashes that we have in our bug tracking system, tracker.ceph.com, to better understand an issue. And they can see if there is a fix for it and what version it is fixed in. Maybe they want to upgrade to that version to have that fixed. Let's take a quick look on the architecture on the Ceph cluster side, specifically for the crash telemetry process. So whenever a daemon crashes on the Ceph cluster, this can happen due to various reasons. It can be an unexpected state, it can be a failed assertion, or God forbid, even a bug. A signal handler will generate a crash dump. It will write it to the local disk. And then the daemon exits and restarts. We have in each Ceph node a Ceph crash daemon, which will check periodically this directory, and it will post new crashes to the Ceph cluster using the Ceph manager module, the crash manager module, which will write it to the database, and then once a day, in case the user is opted into telemetry and into the crash channel, telemetry will query this database. It will compile a report with a crash information and other channels in case the user is opted into them, and it will send it to our backend. So what does the crash report contain? We're talking about the backtrace that is contained in that, but we also have a crash ID and the crash daemon type and name, the Ceph version of that daemon, and some information about the OS, the distribution and kernel version, and if applicable, we'll have some information about the assert. And on the back end, we can combine this with other cluster information that comes from basic channel if it's enabled, like the available and used capacity, number of daemons in that cluster, and so on. But then we have a lot of raw crash reports, and we need to find patterns among them to make it easier to understand what raw reports represent what issue. So let's take a look at a couple of raw backtraces. These are real examples that I received in telemetry. I simplified it so it could fit on one slide. So we can see that these two crashes, they look quite similar, and from a developer point of view, they represent the same issue, but they're not similar. So the differences can happen due to different Ceph versions, code changes, which each version, of course, or different compiler versions, or even compiler optimization. And this affects the symbols and the offsets and addresses. So we need to find a way to tell that they are indeed the same. So we sanitize the backtrace. We remove all the offsets and addresses from the frames, and we do that by using and after that we use regexes to search and replace patterns in the frames, and then to filter out entire frames completely. So, for example, those empty frames are irrelevant to understand the nature of that crash. So now these two raw backtraces are identical, and we can group them together and understand that they represent the same issue. So this is what the crash processor is doing in our backend. It removes the offsets and the addresses, and then it applies the search and replace patterns, and then the filter out patterns, and calculate a signature for each of these raw crashes. And this is how we know to group them together. Another thing that is important to say here is that we support multiple generation or recipes of signatures, which allows for backward compatibility. So in case we find optimizations to a recipe, we can detect that the old signatures are actually the same case as well. And then the crash processor will populate the database, and we will have a lot of good information in the database, but having just the data is not enough. We need to do something with that. And this is what the REDMINE bot does. It takes action. So it will query the database for the most recent crash signatures, and then it will map the crash signature to REDMINE issues. And the way it does that is by searching REDMINE for these signatures, and in case it finds a relevant issue, it will update it. Otherwise, it will create a new issue. And there is a list of different projects, and the bot knows how to pick it correctly. And then the bot will update the issues with essential information that we have from the telemetry database, such as the affected versions, the sanitized and raw backtraces, and it will have a link to the dynamic dashboard. And another thing that I mentioned earlier is that the bot knows how to identify regressions. So, say for example, we fixed an issue that we saw in telemetry, but then we have new reports in telemetry of newer versions that has the fix, but now reporting the same issue all over again. The bot will know to open a new issue and to link it to the original fixed issue, so developers can have a heads up to understand that maybe there is an issue with the fix. Okay, I want to show the custom queries that we have per project in REDMINE. So we have both crash triage and crash queue custom queries. So each project will have on the sidebar here these couple of custom queries. So the triage will have just the new ones, and the queue will have everything which is open. So you can see that according to each project. It's important to say that not all crashes mean Ceph bugs. So there could be issues with the hardware or IO errors that we'll see crashes reported due to that. There could be also environment or resource limitation or configuration issues that end up in crashes. And there can be issues of other dependencies as well. We'll take a quick look at the architecture on the server side. So we'll have the REST API where the telemetry reports are sent to, and then they'll go into the database, and we'll have the crash processor who does all of the sanitizing of the backtraces and calculating of the signature and so on. And then we have the REDMINE bot that queries the Postgres database and maps it to the REDMINE instance. And we also have the Grafana dashboard that queries the database and shows a lot of analysis and panels to developers. And then there's another component, which I don't know if I have time to talk about today, about the signature merger that knows to take a couple of crash signatures and to merge them together in case the recipe has been improved. All right. Please let me know if you have any questions. I cannot hear any things in the chat or anything, so feel free to ask.
There is a question.
Okay.
For bug crashes, what is the best way for a user to track what is happening as a result of a crash in their cluster?
Okay, that's a good question. Basically, right now, the crashes should be synced with REDMINE, so they can search REDMINE. But we're working on having tools for developers, for users as well, to see like a bird's eye view of what's happening with all the crashes in their cluster that they reported, and how they are mapped to issues in REDMINE. So this is something which is ongoing work. That's a great question. Thanks.
And another one for non-bug crashes, is there a source of known issues or best practices to avoid those or learn about them?
I'm not sure I understand the question. So can you please repeat it, Mike?
For non-bug crashes, is there a source of known issues or best practices to avoid those or learn about them?
Oh, so you mean if there are crashes that are known, right? Not none.
Not bug related.
Okay. Again, Tracker is the most reliable source, and every now and then we have some troubleshooting analysis that we have a blog post about. But if there is something specific that you're interested in, please specify that, and we'll see if we can have exactly what you're looking for. Okay, I want to go back and talk about the dashboard that we have. So we have a very powerful internal dashboard for the crashes that allows searching the entire database by backtrace frames, by Ceph versions, signatures of all revisions, search functions, number of affected clusters, and so on. And then we can have drill downs to cluster information, so we can see the capacity of the cluster, the current cluster version, and so on. And we can learn about the trends in crashes through versions. So right now, users can access the data with REDMINE. So the backtraces and crash signatures are in REDMINE. For developers, they do need to have access to the Ceph lab currently to see all of the breakdown of the crash dashboard. And it's really important just to emphasize here that many times we see that users publish their crash, the crash reports in REDMINE, but they remove the signature. This is not a secret. On the contrary, it helps us to map the issues that we see in telemetry with whatever is reported in REDMINE. So please include that. I'll go ahead and I'll show a demo of the dashboard by using an an example of how we can learn about new crash reports of new releases. So we just released Quincy 17 2.5. So we will have in the dashboard all of the crashes that were reported with this version. So you can see that there's the search result page here that tells us about how many clusters have seen this specific issue, how many majors have seen this specific issue. There's a raw count of the crashes in a specific time frame. Here we took it's 5 years, so that's since the beginning of our collection. And we can learn about what's the status in REDMINE as well. So for example, we can see that there's a crash that was reported about a week and a half ago that happened throughout the different versions of Quincy. We see that it needs more info. It happens to 31 different clusters, and totally there were 141 raw crash reports. We can see the breakdown by versions. So that was reported mostly for 17.2.3. Here we have the sanitized backtrace that we can search the entire database for other signatures that have similar frames. So for example, if we're curious what other signatures contain this frame, we can just click on that and I'll move to that tab momentarily to see how many other signatures there are. In case it was a crash due to an assertion, we would see the details here. Here we can see the daily occurrence, information about the affected clusters. So there is a total unused capacity, how many daemons are in the cluster, what current version they're running, and so on. The age of the cluster as well. And here we can take a look at some raw examples. So we'll have a raw crash report here. As I mentioned, some users choose to identify themselves. So here we will have the information which was removed for the sake of the demo, but we'll have contact details of users that identify themselves. And we actually contact users every now and then when we need more information. So we're so grateful for you for helping us with this and providing logs. This is very, very helpful for us. We talked about, okay, so we searched earlier for this frame. So we can see that there are different 4 fingerprints or signatures that have this specific frame. And we can keep and filter out result by adding some more frames to search for in the database. Okay, I'll go back. There's a lot to talk on the dashboard, but I'll go back to the slides. I want to quickly talk about some fixes that happened thanks to reports that happened in telemetry. So, for example, we can see that the telemetry bot opened this issue and it populated all of the relevant fields, such as the affected versions. And we have here the sanitized backtrace, some raw example of a crash dump. And this was picked up by the Ceph team. They discovered that it was a real issue, and they came up with a fix for that and with backports as well. So this happened thanks to telemetry. Thanks for to users who opt in to to the service and help us make a better product. So we have this example as well, another issue that was opened by the Telemetry bot, and the RGW team picked that issue and again came up with a fix for that, which was also backported to Octopus, Pacific, and Quincy. And this is everything here is automated except for the fix, of course. But the bot will update the tracker with all sorts of relevant updates, such as the affected versions and so on. Yeah, and here's another example of an issue that was first reported by a user, and they reported the issue that happened in version 17.00, and the only what they did is to include an example of their of the crash dump, and this is where they included. Oh, sorry. So our engineers looked at this issue here, and they searched it for our telemetry dashboard, and they realized that it started already in Pacific, so not necessarily in Quincy. So it helps us to be more focused and understand when issues emerge, and to have a better understanding of when the problem started. All right. So I think we don't have much time. That again, it's a big subject. Maybe I'll talk just quickly on a couple more examples. So here we have an example of another issue that happened that was reported in telemetry, and a user chimed in and said that they also have that, and they can provide us with logs or any additional information, which also is another use case for the sync with our bug tracking system. Yeah, and like I mentioned, sometimes users identify themselves, so we can contact them for more information, and we're very grateful for your cooperation on that. Yeah, and there's another example here that telemetry helped us to prioritize an issue that first started, it was reported downstream first, and it had the original report had crash information, and we could search the dashboard to better understand where we saw that in the wild as well. I have just 1 minute left, so I think we don't have much time. If you want to take a look at our public dashboards, they're on public telemetry dashboard public.ceph.com. You can see a steady increase. In the last couple of years, we had about 400 something clusters, and right now there are more than 2,000 clusters reporting a total of 815 petabytes. You can see breakdown by minor versions as well in our public dashboard. So you can just change it to minor here, and for example, we can choose Quincy. Obviously, the time window is 2 years, so not going to show results for 2 years. Yeah, it's actually a pretty big query. I can just change it here. Maybe it'll be faster. Sorry. Okay, it did. It returned. So you can take a look and learn about Ceph deployments in the wild in our telemetry dashboards. There is all sorts of histograms and heat maps here as well. You can see some more capacity density charts and have a look at the device dashboard as well. I'm out of time. Sorry about running over. Let me know if you have any questions, and you can always reach out to us, and we'll be happy to answer any questions you have. Over to you, Mike.
All right, great. Thank you. There is a question in chat related to hardware, collecting hardware references and information. Maybe you can answer that in the chat. But thank you for presenting on our work in telemetry, and it's great to see the point to actual successes that it's been able to give us.
Yes, yeah, I forgot just to tell the most important thing. Please opt in with Ceph Telemetry on. Please help us in these efforts. It's been very successful. Thank you, everyone.